done anything. Obviously, that's great to study for us. Just took all the FTQs and put it to randomize it. That's right. So, yeah, and obviously the diagrams. So sure. Okay. Still have a couple of minutes. Before we start, I think the important notice or the announcement is that next week you've got your test one. Next week lecture time. Okay. So I've sent out a detailed announcement about what will be covered in the test one. So you'll have 10 multiple choice questions and 5 short essay kind of questions. Okay. So make sure you read this announcement. Okay, so multiple choice questions. I'm going to upload practice multiple choice questions to give you a little bit more idea. What will be covered? So week 1 to week 5. So whatever we do till this week will be covered in the test one. Okay. Essay questions. There might be some questions on essay questions, what to write and what not to write. So again, so in the tutorials, some of the tutorials the tutor has discussed about the essay questions. Another one. So if you go on each week, I've got some suggested answers for the essay questions. So starting from week 2, tutorial 1 discussions. Now, what does these discussions have? They've got the questions and the suggested, not the suggested answer, but these are the prompts that you can use to write the answers. Okay, so these are some of the points that I will be looking at when I'm going to mark your essay question. So make sure that you're including, so for this one, explain the role of central bank in financial system, highlighting their functions in the monetary policy and financial stability. So what I'm looking at, obviously the main points that I'm looking at are the monetary policy, financial stability, and then the main thing that the central bank do, the bedrock of trust. Within that, so under the monetary policy, I'm looking at interest rate, fractional reserve banking, open market operations, and so on. So I've given you all the points that you need to cover without telling the whole answers. So again, you don't have to memorize all the answers all the answers to the question. But if you prepare in the same line, that should be enough. So for every question, so from where I'm getting these questions are obviously from the teaching notes, right? So if you go on any of the teaching notes, so let's say if I choose the week 3 lecture notes, now you see over here in these boxes, I've got these concept questions. So these are the questions that I'll be testing. Okay, so no surprises. So if you have prepared the answers for these concept questions, that is more than enough. That's all that you need to do. Okay, so prepare the answers for these questions. Okay, and for each of these questions, I've given you those topics that you need to cover. Again, the tutorial, somewhere it should be. It's over here in this week. Discussion points again. So look at those discussion points, okay? So again, over here, we've got all the discussion points. So these are the points that you need to cover. If you're unable to find any of those discussion points for any of the questions, just let me know. I can direct you where you can find those discussion points, okay? So this is a closed book test. Why it's a closed book? Because I don't want to make it difficult. If it was open book, then I'll have to give you case studies and more difficult questions. Okay, so I want to keep it easy because this is just a 100 level paper. Now, at this level, what we expect you to is recall what has been discussed in the lecture. That's all that you need to do. You don't have to really analyze situations. Although you're getting exposed to analytical assessment in your presentations. So that's where you're doing your analysis, and also you're doing research in the FNTEC, like the final research report. Okay, so that's where you're doing your research, and in the presentations, you're doing the analysis. In the test, I want to keep it simple. So 10 multiple choice questions. Again, all the multiple choice questions will be from the practice questions itself. So the practice questions that I'm going to upload, if you prepare for those, you will get some multiple choice questions from there. Okay. So, and then the essay questions. Now, how much you need to write? 500 word max. So the test is in a worksheet format. For each questions, you will have 2 pages. Okay. In 2 pages, you can fit not more than 500 words. That's the maximum that you can fit. Yeah.
Is there a certain format on how you will answer these 60-mark questions, or do we just have to go more in detail? Is there some sort of format or way give us a structure to how to structure the 60-mark questions?
So that's the structure. So all those discussion topics,
it's just based on how many we discuss. Is that
exactly? So let's say if you get these questions, how does blockchain technology enables Bitcoin to achieve more transparent and decentralized financial system? So then I'm looking for these points basically.
Okay.
Okay. So when I'm marking, yes, you're going to write, but in order to make my marking easy, what I'm going to do is look for keywords.
Yeah.
Okay. So as soon as I can see those keywords, I know that we have covered the topic. Okay. So the keywords. So maybe a good strategy that you can do in my previous terms, I've seen that some of the students who actually scored very high marks, they were highlighting those keywords. Okay. So if you have a highlighter, just highlight it. Okay. So you're looking at the transparency, and then highlight how every transaction on Bitcoin blockchain is recorded in a public ledger. Now, in this one, that public ledger is basically the keyword, if you can think of, right? So as soon as I see that you have mentioned that public ledger, I know that you have actually covered that point. Okay. So that's the structure. I'm not looking for any specific structure because you've got very limited time to work. So you cannot write it in a actual essay format, or you cannot write it in obviously not a report format. So I'm not looking for those writing styles, but just the keywords. Now, this 500 words, this is the maximum that you can do practically. It's not possible to write more than 500 words, So yeah, I mean, if you write only 100 words, but if you have covered the keywords, so that key points that I'm looking for, if you have written in a bullet points, okay, so maybe not even in paragraph format, you have written in bullet points, that's acceptable for me as well. Okay, so as long as you have covered those key points, that's it. So if I'm asking you, okay, so mention 3 or 4, 4, advantages of blockchain. So 4 advantages of blockchain that you're going to. So make sure you're at least 4 with examples. Now, the other thing that you must do is examples, using examples. Okay, preferably from New Zealand context. This is for my convenience, because if you're quoting something from New Zealand, I know it. But if you're quoting something from other countries, that means I have to look for it. Okay, so it's not like I mean, that's why I've used the word preferably. So if you're quoting examples from US or China or any other parts of the world, you can do that, okay? Just that it increases my work, but that's all right. I mean, like if I know the context, then it's okay. But make sure that you're using examples that are real. Okay? Don't just make up something. Okay? Use real life examples. So this is where you're going to make a big difference. Like if you are adding an example to every question, to every point, I know you actually understand it. Okay, this is the most important. So use examples to support your answers. Okay, so those points, so you can have bullet points, and then maybe at the end you add a relevant example. Okay? Or in certain cases, maybe like you'll have to add 2 examples. So to like support those points. So examples are the key thing. So when preparing for the questions, think about examples. You can use example from the teaching notes itself because I've got a lot of example. Okay, so you can use quote the examples of Alipay, and then the other companies, like the other case studies, Amazon and all, like the other case studies that I've talked about, like which is, I mean, acceptable for me. But if you want to use your own examples, that is also acceptable. But it has to be real life. So yeah, I mean, as I said, it's a closed book, so no notes, no prompts, nothing. Okay, so you cannot bring any materials. You need to write your answers in the worksheet that we are going to provide you. So, like you basically need to carry nothing. Okay, just bring pens and pencils and highlighters, whatever you want. Okay, and obviously there is no calculation, so no calculators as well. Okay, so I hope that's clear enough. Do we have any questions? Have you started preparing for the essay questions? Yes. Okay, so make sure you start, like, prepare for those essays questions. You don't have to write a lot, but prepare for them because otherwise, if it's like unfamiliar, completely unfamiliar, you won't be able to write. You need to recall the knowledge that we have learned during the class. You cannot make up the information over there. If you're trying to make up the information in the test, I know that you won't get it right. Okay, so prepare for those examples, like for those questions. All right, so yeah, that's about test 1. And this week you have got the tutorial presentation 2. So I haven't received any email about group issues. I'm assuming that everything has worked out now. Okay. All right, so let's now think about artificial intelligence, machine learning, and big data in finance. So these are interlinked but separate topics. Okay, so obviously, artificial intelligence, machine learning, and big data, they both coexist. Like one thing cannot exist with the other, but they're quite different topics as well. So that's what we're going to find out. And then we're going to look at what are the applications that we have in the fintech space. Okay. So the first thing that is here now is the robotic process automation. Okay, so this is not a new thing. This has happened for a long time now. Okay, so in many ways we have encountered like robotic process automation. Like process automation was going on for a long time. So I mean, thinking about Excel, you can even automate like certain admin functions just using Excel. So like this is not a very new thing. Okay, so here let's watch this video and see if you can find anything odd about this video.
Automation is shaking up financial services fast. Traditionally, getting a home loan meant stacks of paperwork, face-to-face meetings, and weeks of waiting. It was slow, manual, and prone to errors. Now, automation is rewriting the rulebook. Banks like ANZ and JP Morgan Chase are leading the way, using smart technologies like robotic process automation and artificial intelligence to cut through the noise and speed things up. Let's look at a real example. At ANZ, a new system called HLQ now handles much of the loan application process. Imagine a customer uploads their documents online: payslips, bank statements, proof of ID. Instead of a person reviewing each one, HLQ uses AI to instantly scan and categorize them. The AI then extracts key data, like income, employment status, and expenses, and matches it to lending criteria. If anything's missing, it flags it automatically, prompting the customer in real time. This means less back and forth and faster turnaround. That same AI can even detect income.
I'm just going to play till there. And so, do you think there is anything odd about that video? Just another YouTube video? What I did was I just used this article about automation, how like ANZ is actually automating this, like the home loan like applications. So I fed it on ChatGPT and just asked it to create a video, and it created a video for me. So I was like, wow, that's a nice one. So now I don't need to read out anything. I can just put it on, and then it's going to take some stock images. But obviously, I'll have to fine tune it. It still takes some time. It took me around 15 minutes to get it right. But yeah, I mean, it just created that video. That was like pretty cool for me. So yeah, ChatGPT it's pretty interesting. You should start playing with ChatGPT. I'm sure you're playing with ChatGPT. You're trying out some ChatGPT, but yeah. But what I wanted to like talk about, other than that you can create videos on ChatGPT now, is this robotic process automation. And banks in New Zealand are actually automating their home loan applications. So this is ANZ, and they're using this particular system called the HLQ Automates, like HLQ system. And Westpac is also using the, Westpac has tied up with Dosh, and they are also using artificial intelligence to, automate the home loan application. The main issue with the home loan application is that when you submit those forms, I mean, like most of the time we are going to use a mortgage broker, and then the mortgage broker will have their own system of collecting data, and then it goes to the bank in all different separate forms, and then there has to be a person, like earlier there used to be a person who has to go through all those information and put it in the bank's format so that they can process it. Now that particular job is automated, so all this different information is going to the bank, and then they're using some form of AI to, streamline all the information and putting it into the bank's software so that they can, process those applications. So that's one application already that we can see in robotic process automation using AI. But then coming back to that concepts of big data, artificial intelligence, and machine learning. So what is big data? Though there is a lack of uniform definition, in general, it refers to handling and analyzing extensive and complex data set, employing techniques using AI, known as big data analytics. So previously, if you think about data, like before the big data era, we mostly relied on quantitative data, okay, so which can be easily expressed in numbers, but now, or like structured data, but now we are looking more into unstructured and semi-structured data. Now, what does an unstructured data mean? Okay, so an unstructured data is your data from, let's say, Facebook, or like, well, I'm still on Facebook, but for you, it can be TikTok or any other like social media that you're using, okay? So obviously there's a huge amount of information that we can gather from your behavior or patterns that we can see on your social media. So social media data are mostly unstructured, okay? And so this is an important source of data even for banks or any other financial institute in order to understand your spending behavior and like other sorts of behavior. Okay, so unstructured and semi-structured data are used in analysis now. But what is the issue? Like, what is the difference between structured and unstructured data? Can anybody talk about that? What is the difference between a structured data, which is, let's say, your bank statement, okay, is a structured data, and what is what is the difference? What is the issue? Have you done some analysis, some statistical analysis in your school? Have you done some basic statistics? If you think about running analysis, okay, using unstructured data, the first issue is that because it is in different forms, okay, so it can be in text format, or it can be in video format or audio format. You don't know how to fit it to your normal, normally accepted analytical tools. Okay? So you cannot fit it with those analytical tools, which means what you need to do is first take this unstructured data, convert it into some level of structure, like give it some level of structure, and then you can use it for your analysis tool, okay? So converting unstructured and semi-structured data, that's where we need AI at the moment. So AI can, efficiently convert unstructured data into a structured data. An example is how many times you're using a certain word in your social media post, okay? So we can look at those and then create a frequency which can give us a trend of what you believe. So let's say if you're looking at buying something, okay, so on your social media post, maybe you are like using that same word again and again. So that gives us, so like use of word can tell us a lot. Okay? So like Google Trend can tell us a lot. Okay, so that's a very acceptable format of research now. Okay, so later I'm going to when I'm going to discuss about open banking, I will share one of my research that I've done using Google Trends, where I've looked at how many times in different countries, in different parts of the world and in different times and different years, the word open banking was searched on Google. And that gave me a trend to understand that when open banking was becoming more, popular in different countries, and that's why obviously people were searching for it. So you can use those trained analysis. So that's about the data, okay? So mostly the unstructured and semi-structured data is constituted in this big data analytics. Now, artificial intelligence then, so defined as the development of computer system capable of performing tasks requiring human intelligence. So AI encompasses a broad area, including machine learning as a subset. So here what it means that machine learning is basically a subset of AI. So then what is machine learning? So it is a method of creating algorithms that automatically improve through experience with minimal human intervention. So then the first step to understand AI, or even to effectively use your generative AI like ChatGPT, you need to first understand the machine learning techniques that was used to train or develop that particular generative AI. Now, there are some steps in machine learning. Okay, so the statistical foundation, machine learning builds on similar, familiar statistical methods, but allows for greater flexibility. So, what are the steps? There's this. So the first step is supervised learning. So what you do is you feed the algorithm a set of historical data, okay, where like that's your data. So let's say you want to predict, like income and spending pattern. So if the income increases, by what rate the spending pattern increases, by what rate spending increases, and then you want to moderate it by some other factors like male, female, ethnicity, and so on. Okay, so if you want to predict that, okay, so if the income is increasing for a male and female, then how much the spending is going to increase. Or if you want to predict the income increases for different ethnic group, then how much the spending is going to increase. So first, what you do, you collect historical data, and then you train the machine learning algorithm. So that's a supervised learning. Then an unsupervised learning stage happens. So where you first, first you have supervised learning, so you have trained it, and then you start asking to predict. Okay. Now, once they have predicted, then you check the information, check the output, if the algorithm is getting it correct or not. Okay, so that's where you're unsupervised learning. So first you're training it, letting it run the model, and then you check the output. Then reinforcement learning. So that's where you are giving feedback to the algorithm. Okay, so these are the places where you have got your output wrong, and you'll have to tune yourself. So these are the mistakes that you have made. Okay, so you're basically giving feedback to the algorithm. So that's your reinforcement learning. Now, once these stages are done, so this is basically this first stage helps to develop the machine learning algorithm, and then you can basically let it go and then explore. Once you've reinforced it with the feedbacks, then the deep learning stage can start, where it uses layered algorithm inspired by human brains, applicable across supervised, unsupervised, and reinforcement learning. So this is where now, once you have given those feedback, it knows where it can get things wrong. It also has the feedback, and then it's going to improve itself. Okay. So those are the three stages that's happening. So before I show, I've done a research using this technique, I can show you that. But let's first understand the differences between AI and machine learning, okay? And these different stages.
Artificial intelligence and machine learning. What's the difference? Are they the same? Well, some people kind of frame the question this way. It's AI versus ML. Is that the right way to think of this? Or is it AI equals ML? Or is it AI is somehow something different than ML? So here's three equations. I wonder which one is going to be right. Well, let's talk about this. First of all, when we talk about AI, I think it's important to come with definitions, because a lot of people have different ideas of what this is. So I'm going to assert the simple definition that AI is basically exceeding or matching the capabilities of a human. So we're trying to match the intelligence, whatever that means, and capabilities of a human subject. Now, what could that involve? There's a number of different things. For instance, one of them is the ability to discover, to find out new information. Another is the ability to infer, to read in information from other sources that maybe has not been explicitly stated. And then also the ability to reason, the ability to figure things out. I put this and this together and I come up with something else. So I'm going to suggest to you this is what AI is, and that's the definition we'll use for this discussion. Now, what kinds of things then would be involved if we were talking about doing machine learning? Well, machine learning, I'm going to put that over here, is basically a capability. We'll start with a Venn diagram. Machine learning involves predictions or decisions based on data. Think about this as a very sophisticated form of statistical analysis. It's looking for predictions based upon information that we have. So the more we feed into the system, the more it's able to give us accurate predictions and decisions based upon that data. It's something that learns, that's the L part, rather than having to be programmed. When we program a system, I have to come up with all the code, and if I want it to do something different, I have to go change the code and then get a different outcome. In the machine learning situation, what I'm doing could be adjusting some models, but it's different than programming. And mostly it's learning the more data that I give to it. So it's based on large amounts of information. And there's a couple of different fields within, a couple of different types. There is supervised machine learning, and as you might guess, there's an unsupervised machine learning. And the main difference, as the name implies, is one has more human oversight, looking at the training of the data, using labels that are superimposed on the data. Unsupervised is kind of able to run more and find things that were not explicitly stated. Okay, so that's machine learning. It turns out that there's a subfield of machine learning that we call deep learning. And what is deep learning? Well, this involves things like neural networks. Neural networks involve nodes and statistical relationships between those nodes to model the way that our minds work. And it's called deep because we're doing multiple layers of those neural networks. Now, the interesting thing about deep learning is we can end up with some very interesting insights, but we might not always be able to tell how the system came up with that. It doesn't always show its work fully. So we could end up with some really interesting information, not know, in some cases, how reliable that is because we don't know exactly how it was derived. But it's still a very important part of all of this realm that we're dealing with. So those are two areas, and you can see DL is a subset of ML, but what about artificial intelligence? Where does that fit in the Venn diagram? And I'm going to suggest to you it is the superset of ML, DL, and a bunch of other things. What could the other things be? Well, we can involve things like natural language processing. It could be vision. So we want a system that's able to see. We might even want a system that's able to hear and be able to distinguish what it's hearing and what it's seeing, because after all, humans are able to do that. And that's part of what our brains do, is distinguish those kinds of things. It can involve other things like the ability to do text to speech. So if we take written words, concepts, and be able to speak those out. So this first one involved being able to see things. This is now being able to speak those things as well. And then other things that humans are able to do naturally that we often take for granted is motion. This is the field of robotics, which is a subset of AI. The ability to just do simple things like tie our shoes, open and close the door, lift something, walk somewhere. That's all something that would be part of human capabilities and involves certain sorts of perceptions, calculations that we do in our brains that we don't even think about. So here's what it comes down to. It's a Venn diagram, and we've got machine learning, we've got deep learning, and we've got AI. So I'm going to suggest to you the right way to think about this is not these equations. Those are not the way to look at it. In fact, what we should think about this as machine learning is a subset of AI. And that's how we need to think about this. When I'm doing machine learning, in fact, I am doing AI. When I'm doing these other things, I'm doing AI. But none of them are all of AI, but they're a very important part. Thanks for watching. Please.
Okay, so that's about like the differences between AI and machine learning and how the whole thing fits in. And also interestingly, he talked about the statistical method and why do we need the whole idea of machine learning? Okay, so like what was the issue with our old statistical method, if you can, like if we start thinking about that? How many of you have done some regression? You know, some regression, you know, where, you know, you use a variable. So let's say you've got, you know, like, okay, so where you've got y is equal to something, you know, like plus x over here, so like beta of x and so on. Has somebody done this kind of equations? No, don't you remember? Okay, let's think about this. So you've got your two, like, let's think about a graph. So we are going to think about income and savings. Okay, so what happens if income increases? Okay, so do we save it or do we spend it? Okay, there are two ways of doing it. Okay, so if income is increasing by $1, then what happens to the saving? Does it increase by the same $1 or it increases by how much? Okay, if we have to predict that, what we will do, we will have, you know, like we're going to plot income and savings into like different axes, you know, y-axis and x-axis, and then we will have like at different levels of income, like how much savings are going to increase. Okay, so if I change the order, so maybe savings over here and income over here. So if income increases by, let's say, $1,000, what happens to the savings? Okay, so if we want to find that out, and so if we have got several observations like that, okay, and then we want to plot it on a graph like this, so like then we can like end up with several observations, right? But in order to find out how much it's going to increase, we need to have an equation so that we can draw a line between that. And then we say that, okay, so if income increases by a unit, by how much unit, the saving is going to increase. So this is your basic regression analysis, right? But what is the problem with this particular statistical method is that we cannot cover all the different observations. So basically, we are just drawing a line between those observations and then trying to predict the slope of that line. Okay, so by how much that, like, because as you can see, obviously that line is going upward. So like, what is the rate at which it's going up, right? The problem is we are missing all these different data. So we have got all these different data points. That's what we are missing. Now, what does machine learning does is instead of taking like drawing just one line, it's going to include all these data points and maybe try to draw a line, something like this. Okay, so it's like not even a line, but instead it's going to take all these different observations and train itself. It's going to train itself on all the different observations, not missing out anything, okay? And that's the strength of machine learning. So nothing is missed out. In our traditional statistical method, all these extreme observations were missed out, okay? And that's why most of the time the statistical method are just like their assumptions, and it is just an approximation. We cannot get anything for certainty. Everything was approximated, okay? But with machine learning, we can have more certainty on our results. So the reliability of our output increases significantly. So that's the main thing about like that's the difference between our traditional statistical method and machine learning. So now there is a lot of job that's coming out in the machine learning area or like the AI space. So the first thing that you need to understand is that reinforcement learning of human feedback, or RLHF. So like, what is RLHF? It's that okay, so reinforcement learning from human feedback. So basically, you are working. So first you get all the outputs, like what the machine learning is giving out. And then as a human in the loop, you look at all those output and it uses human feedback to optimize the machine learning model to self-learn more efficient. So reinforcement learning technique trains software to make decisions that maximize reward, making their outcomes more accurate. RLHF incorporate human feedback in the reward function. So ML, like the machine learning model, can perform tasks more aligned with human goals, wants, and needs. Okay. So that's the idea of reinforced learning from human feedback, and that's where as human we come in the loop. Okay, so what kind of jobs are coming? Like these are new areas of work that is becoming available now. So there's something called the data annotators. Okay, so as data annotators, you will be checking the output that the machine learning algorithms are giving out. And that's why you're reinforcing the algorithm. Okay, so you're going to use, let's say you're a data annotator in the finance field. Okay, so you're going to use your finance knowledge and check if the machine learning outputs that's coming out are accurate or not. If they're correct, then you reward the algorithm in a certain way that will be again designed in the algorithm. Or if it is incorrect, then you also give feedback that this is incorrect and why it is incorrect and what can be done to improve. And that's how you're going to like provide feedback to the machine learning algorithms. So let's say if there is like AI training for finance, so this is a job that I found out that you can work on as well, you know, so like AI training for finance, that's a real job. You can, so these are like contract kind of jobs. So services you'll be providing, you will use your domain expertise to assess the factuality and relevance of text produced by AI model. You will craft and answer questions related to your field expertise in order to help train AI model. And you will use your expertise to evaluate and rank responses generated by AI model. Okay, so like here you are basically checking the work of a machine learning algorithm. Now, like in the finance field, it can be different kind of jobs, right? It can like differ from investment strategy to, you know, calculating interest rates, anything that can be automated. Or even, you know, like when we started with the robotic process automation of home loan, like mortgage, you know, like mortgage application processes. Okay, so that's where you can also work as the human in the loop, where you're going to look at the work of the machine learning algorithm and then provide feedback. And this is a job that is very like lucrative. It's already there. You know, like it can range from, you can see it's from PhD, master's degree to bachelor degree. So depending on your knowledge and expertise, you're going to, you know, like check like different levels of work. Okay, so with a PhD, you might end up checking like much higher levels of automation, but with a bachelor degree, you might end up like looking at more, you know, like basic level of automations. But automation is happening at different levels, right? So this is a job that I found out, and obviously these are all kind of contractual jobs, more of like a gig economy. So along with your other job, you can do this. It pays around $30 to $40 per US dollar, like per hour, which is not bad payment. Okay, so if you consider the New Zealand rates, this is like US dollar, pretty good money as well. All right, so these are the kind of jobs that's coming out, different kinds of job that you can also explore if you understand this whole domain of machine learning and AI. So this is another diagram that we can come up with, as it says that machine learning is a subset of AI. And where does big data fit in the whole story? So big data is obviously providing all the data to the supervised learning, like reinforcement learning and unsupervised learning. So that's where big data fits in. It's providing the data to the machine learning algorithm. Without that, obviously, it cannot exist. And that is the reason why machine learning has become so popular, because we can store a lot of data now, especially like before cloud computing, we were storing it in servers that were locally, like even in the university, obviously you haven't seen like what used to be before Moodle. Before Moodle, there was something called MyWeb, and everything was stored here in the New Zealand, like in the campus, in a local server. Now, with cloud computing, we don't have to do that. So we have got more capacity to store data. And that's why big data is more important. Like, because we can store data, we can collect data, okay, and then sort out data. So, but like, what is the applications and limitations? So broad applications, from image recognition to NLP processing, like natural language processing, deep learning has led to significant advancement. But what is the problem? Like the problem solving, so like machine learning algorithms are adapted to classification and regression analysis, but are not designed for causal inferences. Okay, so let's think about this. This is a very big disadvantage of machine learning. Okay, so it can predict the relationship that yes, Y has a relationship with X, but it cannot really predict the causality, so how much it's going to increase. Okay, so that's one of the biggest issue of machine learning. So in our research that we have looked at, like used machine learning, find it now. Yeah. So in this paper, we were looking at the rising pay, like what happens to the local councils debt to equity ratio. So like we are looking at like CEO remuneration as a predictor of debt to income. So what we were trying to look at is for the local councils, if the CEO's salary is going up, if the debt or the loan that they're taking are also going up, and if that is affected by the election cycles. Okay, so still under review, and it will be published soon. Yeah. So we were looking at that if the CEO remuneration is increasing, then the debt is also increasing for those local council, especially if there is if there is a impact of the local councillors. Okay, so when there is a political competition, especially during those election cycle, if the debt of the councils are increasing. So what we did, instead of using the regression analysis, we used the machine learning to predict. Now here we can only predict if the CEO remuneration is linked to those debt to operating income ratios, but we cannot say by what percentage it was increasing. And you see what it will do through, like we use some statistical softwares to use it, and this is how it's going to give us. So it's going to have some, so here the supervised training is happening. So this is our, variable where we're seeing if the debt is increasing or not, yes or no kind of thing. And then what are the different variables that are impacting, okay? So that's called the neural network architecture. Okay, so this is the main architecture that machine learning is going to use, the neural network architecture. Here basically saying that if the different variables has got an impact on the debt or not. So that's what it's doing. But what it doesn't do is it will not tell us the causal inferences, like by what percentage it's going to increase. So that's the issue with machine learning and statistical methods. So I'm not going to go too much into it, but that's one of the issues of machine learning. The other thing, the drivers of AI and machine learning. So like adoption in the financial service. So like, why are we adopting machine learning so much at the moment? It's because the supply factor, obviously the technology is now more cheaply available. So we've got improved computing power, data availability, algorithm costs has gone down. The financial factors, availability of infrastructure and data to apply the new techniques. So these are the supply side. And then on the demand factor, the profitability. Okay, so if the financial institutions are not adopting AI or machine learning techniques, that's going to impact their profitability. Competition is another issue, and regulation. That's another big issue because there is so much regulatory pressure on the financial institution. They need to use some form of machine learning to work with those regulatory requirements. Okay. Now, the next thing that we need to understand is where does Gen AI or like generative AI fit in all these issues now? Okay. So let's look at this video, and that will give you an idea of where generative AI is, and then we can think about like what are the applications of generative AI.
Everybody's talking about artificial intelligence these days, AI. Machine learning is another hot topic. Are they the same thing or are they different? And if so, what are those differences? And deep learning is another one that comes into play. I actually did a video on these three, artificial intelligence, machine learning, and deep learning, and talked about where they fit. And there were a lot of comments on that, and I read those comments, and I'd like to address some of the most frequently asked questions so that we can clear up some of the myths and misconceptions around this. In addition, something else has happened since that video was recorded, and that is the absolute explosion of this area of generative AI. Things like large language models and chatbots have seemed to be taking over the world. We see them everywhere. Really interesting technology. And then also things like deep fakes. These are all within the realm of AI, but how do they fit within each other? How are they related to each other? We're going to take a look at that in this video and try to explain how all these technologies relate and how we can use them. First off, a little bit of a disclaimer. I'm going to have to simplify some of these concepts in order to not make this video last for a week. So those of you that are really deep experts in the field, apologies in advance. But we're going to try to make this simple, and that will involve some generalizations. First of all, let's start with AI. Artificial intelligence is basically trying to simulate with a computer something that would match or exceed human intelligence. What is intelligence? Well, it could be a lot of different things, but generally we tend to think of it as the ability to learn, to infer, and to reason, things like that. So that's what we're trying to do in the broad field of AI, of artificial intelligence. And if we look at a timeline of AI, it really kind of started back around this time frame. And in those days, it was very premature. Most people had not even heard of it. It basically was a research project. But I can tell you, as an undergrad, which for me was back during these times, we were doing AI work. In fact, we would use programming languages like Lisp or Prolog, and these kinds of things were kind of the predecessors to what became later expert systems. And this was a technology, again, some of these things existed previous, but that's when it really hit kind of a critical mass and became more popularized. So expert systems of the 1980s, maybe in the 90s. And again, we used technologies like this. All of this was something that we did before we ever touched in to the next topic I'm going to talk about. And that's the area of machine learning. Machine learning is, as its name implies, the machine is learning. I don't have to program it. I give it lots of information and it observes things. So for instance, if I start doing this, if I give you this and then ask you to predict what's the next thing that's going to be there, well, you might get it, you might not. You have very limited training data to base this on. But if I gave you one of those and then ask you what to predict would happen next, well, you're probably going to say this. And then you're going to say it's this. And then you think you got it all figured out. And then you see one of these. And then all of a sudden, I give you one of those and throw you a curveball. So this, in fact, and then maybe it goes on like this. So a machine learning algorithm is really good at looking at patterns and discovering patterns within data. The more training data you can give it, the more confident it can be in predicting. So predictions are one of the things that machine learning is particularly good at. Another thing is spotting outliers like this and saying, oh, that doesn't belong in, it looks different than all the other stuff because the sequence was broken. So that's particularly useful in cybersecurity, the area that I work in, because we're looking for outliers. We're looking for users who are using the system in ways that they shouldn't be or ways that they don't typically do. So this technology, machine learning, is particularly useful for us. And machine learning really came along and became more popularized in this time frame, in the 2010s. And again, back when I was an undergrad riding my dinosaur to class, we were doing this kind of stuff. We never once talked about machine learning. It might have existed, but it really hadn't hit the popular mindset yet. But this technology has matured greatly over the last few decades, and now it becomes the basis of a lot we do going forward. The next layer of our Venn diagram involves deep learning. Well, it's deep learning in the sense that with deep learning, we use these things called neural networks. Neural networks are ways that in a computer, we simulate and mimic the way the human brain works, at least to the extent that we understand how the brain works. And it's called deep because we have multiple layers of those neural networks. And the interesting thing about these is they will simulate the way a brain operates, but I don't know if you've noticed, but human brains can be a little bit unpredictable. You put certain things in, you don't always get the very same thing out, and deep learning is the same way. In some cases, we're not actually able to fully understand why we get the results we do because there are so many layers to the neural network, it's a little bit hard to decompose and figure out exactly what's in there. But this has become a very important part and a very important advancement. That also reached some popularity during the 2010s and as something that we use still today as the basis for our next area of AI. The most recent advancements in the field of artificial intelligence all really are in this space, the area of generative AI. Now, I'm going to introduce a term that you may not be familiar with. It's the idea of foundation models. Foundation models is where we get some of these kinds of things. For instance, an example of a foundation model would be a large language model, which is where we take language and we model it. And we make predictions in this technology where if I see certain types of words, then I can sort of predict what the next set of words will be. I'm going to oversimplify here for the sake of simplicity, but think about this as a little bit like the autocomplete. When you start typing something in and then it predicts what your next word will be, except in this case with large language models, they're not predicting the next word, they're predicting the next sentence, the next paragraph, the next entire document. So there's an amazing exponential leap in what these things are able to do. And we call all of these technologies generative because they are generating new content. Some people have actually made the argument that generative AI isn't really generative, that these technologies are really just regurgitating existing information and putting it in different format. Well, let me give you an analogy. If you take music, for instance, then every note has already been invented. So in a sense, every song is just a recombination, some other permutation of all the notes that already exist already, and just putting them in a different order. Well, we don't say new music doesn't exist. People are still composing and creating new songs from the existing information. I'm going to say Gen AI is similar. It's an analogy, so there'll be some imperfections in it, but you get the general idea. Actually, new content can be generated out of these. And there are a lot of different forms that this can take. Other types of models are audio models, video models, and things like that. Well, in fact, these we can use to create deepfakes. And deepfakes are examples where we're able to take, for instance, a person's voice and recreate that. and then have it seem like the person said things they never said. Well, it's really useful in entertainment situations, in parodies and things like that, or if someone's losing their voice, then you could capture their voice and then they'd be able to type and you'd be able to hear it in their voice. But there's also a lot of cases where this stuff could be abused. The chatbots, again, come from this space. The deep fakes come from this space, but they're all part of generative AI and all part of these foundation models. And this, again, is the area that has really caused all of us to really pay attention to AI. The possibilities of generating new content, or in some cases, summarizing existing content and giving us something that is bite-sized and manageable. This is what has gotten all of the attention. This is where the chatbots and all of these things come in. In the early days, AI's adoption started off pretty slowly. Most people didn't even know it existed, and if they did, it was something that always seemed like it was about 5 to 10 years away. But then machine learning, deep learning, and things like that came along, and we started seeing some uptick. Then foundation models, Gen AI, and the like came along, and this stuff went straight to the moon. These foundation models are what have changed the adoption curve. And now you see AI being adopted everywhere. And the thing for us to understand is where this is, where it fits in, and make sure that we can reap the benefits from all of this technology. If you like this video and want to see more like it, please.
Okay, so then it gives you another term to explore, and that's the foundation model to explore now. Okay, so I mean, as I said, like what's happening is it's that the prediction and how it's predicting that's in like developing. So yeah, I mean, that's where AI, machine learning, and then the next phase now is that generative AI, LLM, and chatbots, deepfakes are all kind of fits. Now, what is the adoption? Now we have got some understanding of the differences of AI, machine learning, and big data. So then let's think about what are the adoption across financial systems, where we can think. I mean, obviously, this whole area is developing, and there will be new adoptions as well. But some of the like more tested adoption are sentiment indicators. So utilizing social media data analytics to offer sentiment indicators to bank, hedge funds, and investment platforms. So even in your case, you know, like obviously you're like, let's say if you want to invest in Bitcoins or other cryptocurrencies, how do you do that? To start with, the cryptocurrencies doesn't have a fundamental, so you don't know really when the price is going to go up or the price is going to go down so that you can trade, right? So one of the best way of understanding that is sentiment indicators. So if you follow like what other people are talking about that particular cryptocurrency on social media, it gives you a nice prediction of when the price is going to go up. And instead of doing it manually, you can obviously fit it into a machine learning model. And like once you have kind of trained your algorithm, like it will tell you when to buy and when to sell. That's basically the sentiment indicator bit. Trading signals, so enhancing productivity and reducing cost by processing vast information sources to susceptible to misinformation risk. Now, like obviously signal trading is also another important aspect of trading in the stock market, okay? But the main issue over here is misinformation. Like on social media, there is so much misinformation. So like, you know, if there is a misinformation about a bombing in some country, yeah, and it has never happened. And if you do some trading based on that particular information, then obviously you're going to lose your money, okay? So that's information, and then you've got the anti-money laundering bit, and then the fraud detection. So that's something that he talked about in the like in his video as well, where you try to find out those anomalies in the data, and then you are like going to identify the frauds like that can happen. Now here, like how AI is changing the financial services, you can watch this video at your time. But like what it does is, let's watch this one, then skip the next one. This is the important one.
Tesla stock is crashing. The headlines say Elon's empire is collapsing. But what if they're all...
Contrary to traditional data analytics and robotic process automation, artificial intelligence has 4 special features. The first one is that it will detect change in data patterns and tune the model by itself. You do not need data scientists to keep tuning the model. Secondly, when the data quality is not perfect, it can actually still create useful insights for business to make decisions. Thirdly, when the data is coming in, we do not need to store it and process it, transform it before we can create analytics. It can just stream through the neural network, and the AI engine can pick up the patterns and help business to serve their customers. And fourth is that it can handle unstructured data. Therefore, we can apply AI in places like image recognition or voice recognition. It's different from traditional analytics in a way that you cannot use it for regulatory reporting because you cannot get the model out of the neural network and show it to the regulator. In financial services, we actually apply that in 3 major areas. The first one is machine learning to create propensity models. So we see banks and insurance companies putting machine learning on their website or mobile channels and create real-time target marketing. They actually predict the product propensity of the customer based on their behavioral data real-time. Second application is usually around natural language processing. Some applications like chatbots, some like contract intelligence, where the AI can actually read the free text of the contracts and detect non-compliance in the documents. The third application is in image recognition. We see a lot of fintech asking the customers to take a selfie and also take a picture of their identity document. And the machine will match these two automatically and help them to do KYC and onboarding. To have artificial intelligence work effectively, the financial institutes need to have a lot of big data. So a lot of banks or insurance companies, when they already accumulate a lot of big data, they can actually tap into this pool of resources and create useful business insights. The future of AI lies in passing Turing tests for 1, and singularity point for 2. AI scientists continue to improve the technology, and their aim is to pass a Turing test by which the customer can actually interface with the machine without knowing that they are actually interacting with the machine. There are a lot of gurus in the area that are concerned when AI can learn how to improve itself, and they call this the singularity.
So in this video, it kind of talks about all the different areas, but I think the key point that you need to understand that the issue with neural network is because it doesn't give us how it works, we cannot present it to the regulators. So for audit and other like purposes, we cannot use AI or machine learning at the moment because obviously we cannot explain the regulators how it has worked out something. This is about the algorithmic trading. Okay, so that's another application. So all these things are actually happening at the moment. So I just wanted to give you like what's happening. And I'm playing a lot.
Algorithmic trading involves using computer code to automatically enter and exit trades once certain criteria are met. It can eliminate the effect of emotions on your trading, increase your activity, reduce the time you spend on analysis, enable you to back-test strategies, and improve your execution speed. So how do you get started? Well, first, you'll need to pick a trading platform. There are a range to choose from with IG, including Pro Realtime, MT4, and our web-based platform, which can be customized with APIs. Pro Realtime is suited for traders who want to experience building their own algorithms. It comes with an easy-to-learn coding language and an optimization suite where you can back-test algos before setting them up to work on your markets. MT4 is popular with traders who are after pre-built, off-the-shelf algorithms. These will have a lot of the functionality of self-built algos, but you won't be able to customize them to the same extent. APIs enable you to customize the IG trading platform and build algorithms from the ground up, using a coding language of your choice. But while APIs give you the most flexibility, you'll need an in-depth understanding of coding to get started. Once you've chosen a platform, you'll need to pick a strategy, and there are several to choose from. A price action strategy looks at historical highs and lows, or the open and closing levels, to assess what the price of an asset might do in the future. A technical analysis strategy relies on indicators and oscillators and will act once certain criteria are met, for example, to close trades during periods of excessively high volatility. A combination strategy combines both sides of a price action and a technical analysis strategy, using technical indicators to confirm price action forecasts. You can configure all of these strategies according to the markets, the time frame, the size of the trade, and for technical and combination strategies, information supplied by the indicators that the algo is designed to use. To learn more about trading, subscribe to IG today.
So these are all off-the-shelf, products that is available for you to choose from, and you can actually set up your own algorithmic trading if you have got sufficient fund to trade. Okay, so it's already there. It's like you don't have to really build something ground up, so you can like work on those things. So here is another one that like when Donald Trump used to tweet something, now is on his own social media platform. It used to impact the company's website. So like over here, it says like the F-35 program and the cost is out of control, billions of dollars, and will be saved on military and so on. So it kind of affected the whole, like the stock price in the markets. Okay, I'll not go into that one. There's another one, anti-money laundering. So that's another off-the-shelf product that you can buy from Google. It kind of detects the frauds and so on. Other customer-focused application are credit scoring. So obviously AI is, like using unstructured and semi-structured data for credit scoring. Insurance, so machine learning drives improvement in underwriting and claim process. And chatbots, I'm sure you have encountered chatbots in different levels. If you're, dealing with your bank or any other places, then most of the time you will be first working with a chatbot, and then after that, if your issue is not resolved, you will, go to a human help. So this is about credit scoring, how AI and machine learning is used for credit scoring, automated credit scoring using structured and unstructured data. So make sure you watch this video, and also in the teaching note, you have got more details. This one over here is an example of how AI and machine learning is used in the insurance sector, especially in the automation of claims settlement. And this is an example of the like a chatbot in Bank of America, but obviously PNC, ANZ, and all the major banks have got chatbot in New Zealand now. Okay. Now, what I want to really focus on, okay, so what's going to happen is so AI trends from 2025 and what we may see in the future. Like again, like some of it is already here. So once we are done with this, that's all the topic that I have to cover. Let's watch this video.
Let's start with an obvious one. Number one, what will be the most important trends in AI in 2025? Well, I'm going to share my own educated guesses. I don't have any kind of top secret classified information or anything, but also this isn't my first rodeo. I did take a shot at predicting AI trends for 2024, and well, I think I did all right. Although, a little confession about that video, I waited until March of 2024 to shoot it, so I already had like a quarter of the year to go on. But that's not the case this time. So let's get cracking with 8 important AI trends in 2025. Let's start with an obvious one. Number one, agentic AI. Every time we post a video about AI agents to this channel, viewership spikes, so there's clearly an appetite for understanding this tech. So, what are AI agents? Well, they're intelligent systems that can reason, they can plan, and they can take action. An AI agent can break down complex problems to create multi-step plans, and it can interact with tools and databases to achieve goals. And I think most people are on board with the utility of a well-performing AI agent. Trouble is, today's models, well, they struggle with consistent logical reasoning. They can usually execute simple plans, but when it comes to handling complex scenarios with multiple variables, they often lose track and they make decisions that don't quite add up. So we'll need better models in 2025. Speaking of which, trend number 2 is inference time compute. Now, during inference, an AI model goes to work on real-time data, comparing the user's query with information processed during training and stored in its weights. Newer AI models are extending inference processing to essentially spend some time thinking before giving you an answer. And the amount of time it spends thinking is variable based on how much reasoning it needs to do. So a simple request that might take a second or two, or something larger and harder might take several minutes. And what makes inference time compute models interesting is the inference reasoning is something that can be tuned and improved without having to train and tweak the underlying model. So there are now 2 places in the development of an LLM where reasoning can be improved: at training time with better quality training data, but now also at inference time with better chain of thought training, which could ultimately lead to smarter AI agents. All right, trend number 3 is very large models. Large language models consist of many parameters which are refined over the training process. Now, the frontier models in 2024, they're in the range of like 1 to 2 trillion parameters in size. The next generation of models are expected to be many times larger than that, perhaps upwards of 50 trillion parameters. But if 2025 is the year of enormous models, it may also be the year of number 4, very small models. Models that are only a few billion parameters in size. And yet you don't hear the phrase only a few billion very often, but there you go. And these models, they don't need huge data centers loaded with stacks of GPUs to operate. They can run on your laptop or even on your phone. Actually, I have the 2 billion parameter IBM Granite 3 model running on my laptop, and my device doesn't even have to break a sweat to run it. So expect to see more models of this size tuned to complete specific tasks without requiring large compute overhead. Now, do you know what the most common enterprise use cases were for AI in 2024? Well, according to a Harris poll, it's improving customer experience, IT operations and automation, virtual assistants, and cybersecurity. Looking ahead to 2025, we will see more advanced use cases. So think customer service bots that can actually solve complex problems instead of just routing tickets, or think about AI systems that can proactively optimize entire IT networks, or think about security tools that can adapt to new threats in real time. Now, when I first used generative AI back in the day to help me build a beer recipe, the context window for that LLM was a mere 2,000 tokens. Today's models have context windows measured in the hundreds of thousands or even the millions of tokens. We are getting close to number 6, near infinite memory, where chatbots can keep everything they know about us in memory at all times. We'll soon be in the era of customer service chatbots that can recall every conversation it has ever had with us, which hopefully we'll consider a good thing. Okay, trend number 7, that is human in the loop augmentation. Now, perhaps you heard about the study where a chatbot outperformed physicians in clinical reasoning. So 50 doctors were asked to diagnose medical conditions from examining case reports. A chatbot presented with the same cases actually scored higher than the doctors. But where this gets really interesting is some doctors were randomly assigned to use a chatbot to help them in this study. Now, the doctor plus chatbot group also scored lower than when the chatbot was asked to solve the cases alone. And that is a failing of AI and human augmentation. An expert paired with an effective AI system should be smarter together than either of those two entities operating by themselves. But look, prompting LLM chatbots can be hard. You got to tailor the right prompt. You got to ask for things in the right way. So we need better systems that allow professionals to augment AI tools into their workflow without those professionals needing to be experts in how to use AI. So expect more to come in this area. Now, the final trend. In my 2024 trends video, I actually turned this one over to the audience, asking which AI trend do you think will be important in the year ahead? And I'm so glad I did. Hundreds of viewers shared their thoughts. Well, I know when I'm onto a good thing. So trend number 8, that one is over to you. What do you think will be an important AI trend in 2025? Let me know in the comments.
All right, so some of the trends has already happened. So agentic AI is already here, and we know that's a thing now. And also the near infinite memory, although it's not near infinite, but then you can really store a lot of information on ChatGPT itself about yourself. So it's already here as well. The token size has increased immensely if you have used the GPT-4 or okay. So yeah, I mean, those are like some of the trends. And finally, to finish up, I'd ask you to focus on this question. So explore the role of big data in AI and ML, focusing on how the different types of structured and unstructured, like data types are like utilized in the insight. Identify and examine a real-world application of AI and ML in finance, like fraud detection, customer service chatbot, trading algorithm, discuss the benefits and challenges faced, consider the ethical and legal and technological advancements. So that's another issue, like what are the ethical and the legal issues? And also, like predict one of the innovations that could revolutionize the financial industry. So if you I'm not going to do this activity now because I know you're already tired, but if you do this, like think about these questions, once you're like when you're reviewing this particular session, then you would be preparing for the test as well. So you're going to get questions like from this site where you'll have to kind of like identify and examine this real world application and then think about what kind of data that is required, the structured and unstructured data that is required in that application. Think about an example and then comment on the ethical and the legal issue that is there in that particular real world application. Okay, so prepare for this one, like these questions, and that should be enough for this chapter. Okay, but also like move to the other concept questions to give a broader context. Okay, so I'm gonna stop here. Does anybody have any question? Are we all good? Once you start preparing for your test, make sure you start preparing early. If you've got questions, please email me. Okay, I can, like, if you think that like you need some feedback on your responses, I'm happy to give you some feedback on your responses if that will help. So yeah, I mean, I'm open to that as well. But the test is in person. Okay, so you need to be here in the class to take the test. Okay.
So are the practice MCQs up on Moodle or?
No, it's not yet. I'm going to upload it like once I go back to Tauranga. Any other questions? No. Are we all good?
Yep.
Excellent. I'm happy.
Ish. Oh, we still got full. Yeah.
Any questions online?
Nope.
No, all good, thanks.
Right, I'm going to end the call now.
Thank you.
Thank you.